Hello everyone. This video presents the solution to the most challenging problem that I uploaded in YouTube on relative equilibrium of liquids. And this is example 6. Here is the problem. A cubical open tank 1 meter on a side contains water to a depth of 0.5 meter. The tank alone weighs 500 newtons. If the tank is placed on an inclined plane with coefficient of friction zero point 0.3, 30 degrees to the horizontal, determine the following: the acceleration of the tank, the angle that the water surface makes with the horizontal, and the maximum pressure developed. So this is the situation. Originally, the tank is in upright position, so that's why the original water level is this red line here, parallel to the inclined plane when it is upright, so 0.5 meter deep. So the volume of water therefore is zero point 0.5 cubic meter because this is a cubical tank. 1 meter by 1 meter by depth 0.5. Then the angle is 30 degrees. So when the tank is still at rest or held at rest, this water surface will remain horizontal and this angle is also 30 degrees. So the weight that will slide along the inclined plane would be the weight of water plus the weight of the tank, which is 500 newtons. So that will be counteracted, or the reaction here is normal reaction N perpendicular to the inclined plane. And of course, friction is opposite. So it is up to the left, zero point 0.3 of the normal. And the angle that the vertical makes with this normal is also 30 degrees, as shown in the figure. So to solve for that acceleration, we sum up forces along the direction of acceleration equals mass times acceleration, and forces in the direction of acceleration is positive, and that is W plus 500 sine of 30. But let's compute for weight first. This is, by the way, the surface is horizontal when the liquid is at rest. Then when it is now accelerating, the surface will be represented by this yellow dashed line. And we will consider this boundary later for the calculations of theta and for answering questions number, the second question and the third questions. So weight is specific weight of water, 9,810 newtons per cubic meter, times the volume is 0.5 cubic meter. So it is 4,905 newtons. Then from static summation or dynamics, summation forces along the tangential or along the direction of acceleration equals mass times acceleration. So the normal force, summation forces along normal equals 0 is quantity W plus 500 cosine of 30. So 4905 plus 500 cosine of 30. So the normal reaction is 4680.87 newtons. Then apply summation forces equals mass times acceleration. So forces in the direction of acceleration is treated positive. That is quantity W, or 4905 plus 500 sine of 30 minus 0.3 of normal minus 0.3 of 4680.87 equals mass. So the mass is weight plus 500, or quantity 4905 plus 500 divided by 9.81 times the resulting acceleration, which is parallel to the inclined plane. So the acceleration can now be computed. It is equal to 2.356 meters per second square. For the second question, the angle that the water surface makes with the horizontal. So that's the angle here between the horizontal line, horizontal surface, and this yellow dashed line. So I'll call that theta, and the formula, remember, tangent theta is ax over g plus minus ay. So tangent theta equals, this is theta, this is also theta, horizontal and the yellow dashed line. Ax over g plus minus ay, where ax is 2.356 cosine 30. Then AY, because the y component of acceleration is downward, is negative. So we use minus here. AY is 2.356 sine of 30. So tangent theta is 2.356 cosine 30 degrees over 9.81 minus 2.356 sine of 30 degrees. So we can now compute theta. It is equal to 13.30 degrees. Then the last question, the maximum pressure developed. Since we expect that the surface will look like this, so it will drop here because the acceleration is going to the right and downward. So this part will rise a little, then this one will drop a little. So let's isolate this yellow dashed line and let's enlarge it. So I'll call this B, and because B is the point deepest or farthest from the surface, then the maximum pressure occurs at B. So this is the enlarged boundary of this yellow line. This is point B. Then let's denote some of the information here. So I draw a line from this left corner to perpendicular to this edge here. So let's transfer it here. And the angle that the yellow dashed line makes with the blue line is 30 degrees minus theta. So 30 degrees minus 13.3, so 16.7 degrees. So I'll denote that by y. So this is also y, and I'll denote that by y1. This is 1 meter, and the angle here again is 30 degrees, or this is 30 degrees minus theta, so 16.7 degrees. So if that is 16.7 degrees, the measure of the angle here is 90 degrees minus 16.7 is 73.3 degrees. Then let's draw the height, or HB. We'll call that HB, and the angle here, remember, is 30 degrees. So let's set up the equation for maximum pressure at B. It is static pressure at B, which is gamma of water times HB, because this is exposed to the atmosphere. So the static pressure at B is simply gamma of water times HB. Then it is magnified because there is y component of acceleration by 1 minus AY over G. So we use minus because, as I said, AY is negative or downward. So let's solve for HB. Let's enlarge this triangle here. But before that, let's solve for y1. Tangent of 16.7 degrees equals y1 over 1 from this right triangle here, because that's 1. So y1 is 0.3 meter. Next is we want to solve for y. Since no water is spilled, then instead of volume, we can use area because the tank is cubical. The width perpendicular to the board is constant at 1 meter. So we equate the final area of waterline section bounded by these yellow dashed lines, this one, to the original area, which is 1 meter by 0.5 meter or 0.5 square meter. So the area of the trapezoid, this trapezoid here, is 1/2 of quantity y plus 0.3 times 1 meter. That's the area of the trapezoid, and it is equated to 1 times 0.5. So I'll enlarge this part to analyze HB. So this is B, this is HB. So again, area of trapezoid, 1/2 of y plus y1, which is 0.3 times 1, is equal to the original area of water section, which is 1 meter by depth 0.5. So from here we can solve for y. Y is 0.35 meter. So if y is 0.35, then plus y1, which is 0.3, so meaning the whole of this is 0.65. So again, this angle is 30 degrees. Angle between the vertical and this normal here is 30 degrees. Then this is 73.3 degrees. Therefore, the angle here, the measure of this angle is 180 minus 30 minus 73.3, and that is 76.7. This is HB, and this is 0.65, 0.35 plus 0.3, and this is 76.7 degrees. So by sine law, HB as to sine 73.3 equals 0.65 as to sine 76.7. So we can now compute HB. 0.6397. Then substitute into this equation here. P max at B is 9.81 times 0.6397, quantity 1 minus 2.356 sine of 30 over 9.81. Finally, we can now solve the maximum pressure at B, which is equal to 5.522 kilopascals. So as I said, this problem is challenging, but for those who want to excel in civil engineering and in mathematics and physics or mechanics, then you should accept the challenge by solving challenging problems, not just the very simple ones, because you will develop by accepting the challenges in life by solving challenging or difficult problems. That's all.